This is problem 27.46, and it says that we want to determine the equilibrium charge on the capacitor in the circuit as a function of R, where big R is the resistance of this resistor here. So if we didn't have any of these resistors, it'd be really easy. We know that, well, the maximum potential difference across this capacitor would just be delta V battery. But of course, we do have the resistors and we have to deal with them. Now, when C is charged, there is no current flowing on this branch at all. That means the current is either flowing like this or it's flowing like that. Now, if it flows down this path here, the current going through the 3 ohm resistor and the 80 ohm resistor is the same. And we know that they are in series like this, and we can just add up the resistance for an equivalent resistance, 83 ohms. Because they're in series, we just add it up. Now, same thing for these two. They have the same current going through them, and that's going to be 2 ohms plus R. So what we're going to say is that this current here, the left-hand side current, is equal to 5 volts divided by 83 ohms. And on the right-hand side, we have 5 volts divided by 2 plus R times ohms. Now, the thing is, we want to know how much potential do we have on this side of our capacitor and how much do we have on this side of the capacitor. Now, what we see is that we're going to have the charge moving from here, and then before it's fully charged, it's going to go through this resistor and then pile up right here. And for the other side, it's going to go through this resistor and pile up right there. So what we say is that VL is equal to, we have the 5 volts here, minus R times I, so the resistance here, times what is the current here, 5 volts divided by 83 ohms, and that's going to be 4.82 volts. On the right-hand side, it's the same thing. The current's going to go like this here. So we're going to have 5 volts minus, and then 2 ohms times the current, which is 5 volts divided by 2 ohm plus R, and that's what we get here. Now that means delta VC, the potential difference across our capacitor, is just the left-hand side minus the right-hand side, and that's going to give us this here. Now the last thing we need to do is just multiply that by the capacitance to figure out what the charge is. So we multiply that by 3 microfarads, and then we get this as our answer here. Notice how I've kept my units everywhere. They're going to cancel out once I find out what R is. Now B, it says, evaluate the charge when R is equal to 10 ohms. Pretty easy. I take this equation, insert 10 ohms into it, and I do the math, and I find Q is equal to 1.96 microcoulombs. C says, can the charge on the capacitor be 0? If so, for what value of R would it be 0? All we have to do is say, well, okay, if Q is equal to 0, what is R? What we do is we set Q is equal to 0, solve for R, takes a couple steps, but we get R is equal to 53.3 ohms. So what we see is that for this setup, if the resistance here is 53.3 ohms, we aren't going to have any charge buildup on this capacitor at all. Our current's just going to completely bypass it during the circuit, and it's not going to build up there. Now the next question says, what is the maximum possible magnitude of the charge on the capacitor? And for what value of R is it achieved? What we're going to see is that if R has no resistance on it at all, so there's no resistance on it, we're going to have a maximum value for the charge buildup on our capacitor. So we set R to 0, and then we just solve for Q here, and we get 14.5 microcoulombs. Now lastly, it says, is it experimentally meaningful to take R is equal to infinity? So what would it mean if we said R is equal to infinity? Now what it would mean is if we disconnected this completely. So yes, it is meaningful. If we disconnect this from the circuit, we essentially have like an infinite resistance because there is going to be no charge that's going to be able to travel down this path. So what we say is that, well, what does it imply? We plug in R is equal to infinity here, and we get something divided by infinity is essentially 0. So then we get Q is equal to 0.54 microcoulombs.